Okay, for number 2, if you see the diagram, and I do see the diagram, and what I notice about is P0, P1, P2. I see a series of intersecting chords, but they go on to say that where these intersecting points occur, it forms an equilateral triangle of length side 1. So this is 1, that's 1, that's 1. All right? Now again, what they claim over here is that the length segments, P0, N0, let me look at that. Yeah, see it's labeled 4, and P1, N1 is 3. Let me just take a look at that. P1, yeah, I see that 3. And the P2, N2 is going to be 2. And it's nicely labeled, by the way. It's a nice, easy diagram to look at. They go on to say X is equal to M naught, P naught. I do see that clearly labeled. Let me see, P1, M1. I'm just looking at the picture. P1, M1 is Y. Yeah. And P2, M2 is Z. So the diagram's labeled pretty nicely. Now, I'm going to post 2 links in the solutions guide about the intersecting chord theorem. And let me just briefly go through that with you. You have a circle, and you have 2 chords intersecting. And it doesn't matter how they intersect. If they intersect, these are chords. And I'm going to say the length here is A, and that's B, this is C, and that's D. What the intersecting chord theorem says is the product of their line segments for each chord. So it would be A times B would equal C times D. And again, in the solution guide, I'll post a link to that. All right. So what I want to do is I want to start writing things down about the chords. And I see a chord here, and I want to take another chord that intersects it there, and I'm going to take this chord over here. So what do I know about that? I know that y plus 1 times 4 is the same thing as, again, the point of intersection here is this point of intersection. That's why I'm saying y plus 1 and 4. And what do you get over here? X times 3. Y3, 1 plus 2 is 3. So that's going to hold. I just don't know what X and Y is at this point. So, and I don't know what the question is. I'm just kind of figuring this out. And I get my eraser out. And I want to take another intersecting point. And that was the intersecting point at P0. I guess I should write that down. This happened at P0, or P naught. Let's do P1. So the point intersecting at P1 would be these 2 chords over here. Whoops. Sorry about that. So let's do P1. What do I see? I see 3 times 1 plus A. I'm going to take a P1, by the way. It's going to be Y times 5, or 5Y. All right, let's do, I guess I got to do P2 now. And I'm going to get my eraser out. Whoops, that's not an eraser, is it? I think my eraser is bigger. Again, we'll get to the question. What am I doing over here? I guess I'll do we did P0, we did P1, now I'll do P2. P2's here, and let me just draw the chords at P2. They intersect at P2. All right, nothing like this over here. All right, let's write this down. And what do I see? I see 3 plus 1, which is 4, times Z. Whoops. 4 times Z is going to be equal to X plus 1 times 2. All right, so I got 3 equations, 3 unknowns. I don't know if I have to figure out what X, Y, and Z are, but let me just say, I don't. I have to compute the sum of X plus Y plus Z, and I'm hoping it's going to be easy to do. But I want to rearrange this equation so it's easy to do. I'm going to write them in what I call the standard order. So the first equation I'm going to write down, whoops. The first equation I'm going to write down is 3x minus 4y equals 4. Let's see, that's 3x. I'm taking away 4y from both sides equals 4. Let me do the next equation. And there I see 5y. I'm going to write in standard order. And then I'd see minus 3z. And then I'd see a 3. All right, let me do this equation over here. I would see 2x let's see what else I get. 2x minus 4z. And so I'm doing that. 2x minus 4z, that equals minus 2. Let me make sure I did that right. So I get the 2x, 2, took away 2 from both sides, that's minus 2. Yeah, it looks okay. All right, I'm looking at this thing over here. Something's disturbing me about this is that negative 2 there. So I'm going to multiply both sides by minus 1. I get minus, plus, plus. Then what I notice immediately by doing that, if I just add these three equations together, what do you get? You get x plus y, right? Because 3x minus 2x is 1x. 5y minus y is a y. 4z minus 3z is a z. I'm adding three equations together, by the way. 2 and 3 is 5, and 5 plus 4 is 9. So what's the solution over here? 9. And again, we're using the intersecting chord theorem or just simply the chord theorem to do that, all right? I'll put links in the solutions guide for proofs of those things and visualization of those as well, all right? Thank you.